It's amazing to see, by the way, all of you show up. So first of all, a huge round of applause for everyone who is in this room right now. I think for us, like, me and Max have been on this journey, like building this community is such a key part of what got us here. Few stats for you is like, at this point, like we feel like we have like around 200,000 developers like actively who build applications, and it's day-to-day do development on top of Temporal platform. Like we feel like it's roughly kind of growing at a rate of like 9 to 10% month over month, so roughly around 180% growth like since the beginning of this year. One of the more integrated part of the Temporal like community that we have built here is our Slack. I love the engagement that goes up over there. You see Max on our Slack all the time. I think that is where, by the way, like the product where it is stands right now is all of that amazing engagement that happens on our Slack community. So like, please, like this excitement that you bring to this event, the excitement that we see around the product, the excitement that we see in our community, please keep on pouring that in, because that's how we make the product even better and better. So one of the awesome things about the community we have built around the product is it's not just us building. It's a lot of you folks out there who are contributing to make Temporal even better and better. A very good example last year was Temporal Lite, which was contributed by DataDog, which actually became the foundational technology on how the next generation of CLI experience looks like. And DataDog is, again, have an amazing contribution coming in recently, and I'm going to invite Jacob Legrone to come up to the stage and talk about that. So Jacob.
Thank you, Samar, for the opportunity to be up here today. I'm really excited. Let me just go back. Okay. I am Jacob Legrone. I am a software engineer on the Temporal platform team at DataDog. And we've been self-hosting our own Temporal clusters in production for about the last 3 years. And in that time, we've had the opportunity to learn a lot of our own operational lessons about running Temporal. What we found is that Temporal itself is a complex system, although the documentation and everything that the Temporal team does to support it is really great. It's still a complex system. There are a lot of metrics and logs that come out of the box that make it really great to monitor, but that also means that it's a lot of work to keep on top of all of the failure modes and potential scaling indicators that we need to keep track of. So that's why I'm really excited to announce today that we've launched an official DataDog integration for monitoring Temporal Server. The integration brings together all of the metrics and logs emitted by Temporal services and gives you a great starting point for running your own servers with an out-of-the-box dashboard and a handful of recommended monitors. For example, one aspect of Temporal that's important to monitor is your sync match rate. So a low sync match rate can indicate that workers are unable to keep up with the throughput on their task queue and might need to be scaled up. So our dashboard automatically highlights task queues that have the lowest sync match rates so you can take action. Over time, we aim to include more features like this with the integration as we learn more lessons of our own and also get feedback from you and the community about what you'd like to see. To try it yourself, you can head to the Integrations tab in DataDog and follow the onboarding instructions. And if you're running your own storage backend, then this also pairs really well with our existing Cassandra, Elastic, Postgres, and MySQL integrations. And we have a second announcement, which is that you can now instrument your workflows and activities using our native DataDog tracing library for the Go SDK. This has a couple advantages over the existing open tracing and open telemetry options that exist, although those are both still supported by DataDog as well. So the first advantage is that workflow and activity logs are automatically linked to your traces, so it's easy to pivot back and forth between logs and APM while you're debugging. The second advantage is that workflow spans in DataDog can now accurately reflect the actual duration of your workflow executions as they show up in Temporal. Other tracers only emit short spans at the beginning of each workflow execution, but with DataDog we're able to compute deterministic span IDs that allow us to close spans as workflows complete, even if that's days or weeks after they started. This also means that you can query workflows by duration directly in DataDog, even after those executions have been dropped or archived by the temporal service. This can be super useful when you want to find out if a deployment had unintended consequences or if workflows are nearing their timeouts. That's all we have for today, but we're not anywhere close to done. We've heard from many of you that Temporal Cloud and Temporal SDK integrations would be nice to have, so please stay tuned and keep the feedback coming. I'd also like to thank the Temporal team and all of you in the community who make Temporal such an engaging and welcoming project to contribute to, and I'm already looking to seeing you all next year. Thanks again. Back to you, Samar.
Thank you, Jacob. So, thanks a lot, Jacob. Jacob and DataDog has been such an amazing partners for us. Like they have made amazing contributions. By the way, like you have no idea how much time people ask for help on our Slack and say, oh, we are having a problem running Temporal in a production environment. The first thing that I typically ask for, okay, can you give me some snapshots or screenshots of your dashboard? And the response I get is, oh, we haven't set that up. Now you don't have an excuse. There is use this and make sure next time when you report an operations issue, it comes with dashboards also for us to help you. So earlier you heard Max talk about durable execution. So no more workflows, durable execution is, so last year we coined this phrase, durable execution, to kind of describe the way the Temporal open source platform kind of increases the software reliability, expand the visibility, and accelerates feature velocity, makes the developer more productive. It's been really encouraging to see how other people in the industry have now started describing their systems also with similar terminology. People who've been following the journey for me and Max, it's awesome to see the story, the storytelling evolve over time. You guys have no idea how hard it has been for us to explain what does Temporal do. And eventually, the more sticky this durable execution term gets, hopefully we don't even have to explain, we just say durable execution. So help us get there. So, but for us, the Temporal platform is a combination of clients, SDKs, primitives, that people love composing to solve all sorts of, build all sorts of applications. Max went over a few patterns earlier. And services that basically provides that abstraction to make durable execution more approachable for all developers. So we've been a big believer in this idea of durable execution for a long time now. And especially in the last 4 years since starting Temporal and all of the experiences with running more than 1,000 organizations at this point. I shared some our community numbers earlier, where we have now experience with thousands and thousands of developers who are using these abstractions. We are convinced beyond any doubt at this point that this is the path forward. This is how we are going to reliably automate the world, by building on top of these abstractions. But I think we have only taken the first few steps now. Since Rust Replay, the team has been doing amazing work to kind of move the platform forward. If we feel that durable execution is going to be the way of life for all developers, we need to invest into it to make it more approachable. Which means so it spreads faster within engineering teams. It needs to be approachable to developers, doesn't matter what language they use. How many years of experience that they have, and what are different ways that they want to learn the system. It needs to be more adaptable. What does that mean? If durable execution is going to transform the software development, it needs to work with different technical stacks. We need to meet the needs of every developer where they are. So that's why you look at all of the investments that we typically make around how an engineering team is architecting, designing, expressing different patterns, testing their code, deploying, running, monitoring. When an application is running in production, we always try to integrate with the stacks that they are used to meet where they are. If durable execution is going to become the default means to reliably automate the world, it needs to become more applicable to a different business circumstances. So we keep on seeing patterns around, there might be business requirement around low latency. There might be business requirement around high variability of those workloads. And most importantly, people are running mission critical apps. So people will come to durable execution with an expectation that it needs to be highly, highly available and reliable. So we need to invest. We have made tons of investments around all of those dimensions to make it more applicable to all sorts of business needs. The team has been super busy throughout last year. I won't go over all of those items. And later, basically the key thing we want to get, all of those investments are put into the system to make this experience fundamentally better for all developers. Next, we are going to be doing a demo and taking a deeper look in some of the key investments like workflow update, schedules, and worker versioning. So I'm going to invite Yimin Chen, who leads the Temporal server team, to come up on the stage and walk through a few scenarios with me. Welcome, Yimin.
Thank you, Samar.
Okay, so while Yimin is setting up, so I'm going to be talking about, one of the first things we'll be talking about is workflow update. This is one of the amazing new primitives we have added to the platform after a very long time. So people who have some experience working with Temporal, one of the key friction points they typically run into is, we have this primitive signal. You can send data into a workflow, but then you cannot piggyback a response. We have another primitive like query, which allows you to retrieve data out of a workflow synchronously, but then you cannot mutate the state. So what we typically find is there are needs from an application where they want to send a request in, have the application do some work for you, and then synchronously send a response back. And some of the times those applications have very strict latency budgets and requirements to live within. So what they end up doing is they send a signal, mutate the state, have a worker running on the same host, have the workflow execution route an activity to run on the same on that host which send the request in, to piggyback a response to unblock the app. It's doable, lots of work, and this is where the new primitive we are going to be talking about, workflow update, just makes it so simple. All of that you do not need to do anymore. You just send an update, synchronously wait on a response, and then after the workflow finishes and processes your request, it unblocks the caller. This primitive, we expect it to be very useful. A lot of interactive applications, like money transfer, we are going to look later. And applications like page flows, especially things like background checks, customer support systems, will heavily rely on this primitive. Yamin.
Right. Yeah, super excited to have the chance to showcase some of the awesome new capabilities we recently added to Temporal platform. Before I start my demo, I wanted to give you a very quick overview of the demo setup. I have a little demo that we prepared, and I deploy it to my laptop, connecting to our cloud. And so everything will be powered by our Temporal cloud. There will be two major scenarios that I will try to showcase here. The first one will be a single money transaction transfer between two accounts. And the second one will be a batch transfer, where I will do a batch transfer between a bunch of accounts.
So, Yamin, let's initiate a transfer. Let's look at some running code.
As soon as I click on this, we will have a real Temporal workflow running in the cloud. Yep, we have it here. Let's take a look on what the code actually looks like. So this is the actual workflow that is currently running. The thing that I wanted to point out is that I have just registered a few updates. And for each, for example, here I have 3 updates. For each one of them, they will handle one interaction request coming from the web UI, and they are all synchronous. At the end of this, I have this workflow waiting for the transaction to complete. So maybe we can take, and also one thing important to point out is that when you register your update, you had a chance to validate the request. And so here is what you can put your logic. If you don't like this update request, you can reject the request. For example, if the amount of the transfer request is greater than some number, you can just say, okay, you cannot do that.
So, Yamin, let's try to transfer $1 million to see how that validation handler kicks in.
Let's try to do that. So I will do this, try to send my money to my saving account, and let's do $1 million.
I am rich.
Right, yes. Let's do that. All right, so as you would expect it, we have this max amount of limit that prevent your transaction from happening. We can take a look on how this is showing up on your workflow. So here we actually see 2 updates coming in, but the last update that trying to actually do the transfer was not showing up, and that's because the validator rejected your update, and when Temporal sees the rejection, it actually not writing this thing to your workflow history. This will prevent a bunch of invalid update coming to you and spamming your history. All rejected one, just like as if it never happened.
This is so cool. So like I think this is a primitive just registering and handler where now you have protection for no one spamming your workflow execution by sending all of those trying to get rich like me. And so that's amazing. Yamin, now let's run a real transaction, something sane, and see how this looks like.
Sure, let's do 1,000. Yep, and the transfer goes through. And we can take a look on what it looks like on the UI. So as you can see, actually I wanted to zoom in there, and you can see that we actually have 2 activities that have been triggered by this update, and they are pretty fast. So you see that they are here. So we have a successful transfer.
Awesome. So, but I mean, like everyone who's been coding up these kind of use cases on top of Temporal, like understands like a lot of times these transfers do not happen as expected. There are scenarios where in the middle of this transaction, it fails with an unrecoverable error. How does a workflow update looks like in those situations?
So we can try one case where it will fail with an unrecoverable failure, and let's see how we compensate that. And this will be like in most real scenario, this will be, let's say we try to transfer money again, and this time I'm going to do save to my piggy bank. And let's put some reasonable number, just $100. But it failed, and we got a very clear message that you cannot do this because your account is frozen and this is non-retriable. So we wanted to take a look on what exactly happened to the workflow. All right, so the most interesting part would be the last update here. And one thing interesting to point out is you can see from the timeline view, we have this update which have 2 activity and one of them failed. And then you can, if you notice that we have 2 compensation going on activity, but your update actually finished before your compensation started. This is where we were able to return as soon as possible to unblock your UI where a human or something is waiting that we want low latency response. And then some of those compensation may take longer time, which your workflow can handle, and maybe it will take a long time and nobody is waiting on that. This is very powerful, but people may get confused on how this is actually implemented. Let's take a look on how the code looks like. It's actually pretty simple. So here is the real update handler code that we use Saga pattern. So before we actually execute the withdrawal, we append some action that we need to compensate if this operation failed. So we add it to this pending compensation. And if nothing wrong, we proceed. And before we do the next deposit, we append another compensation if this thing failed. And then we finish our update. And by the time when we do this, our UI will be unblocked. It will return, and the web UI can move forward. But inside the workflow, as soon as that is done, we will move forward from here, and then we check, oh, something goes wrong, then we really need to do some compensation, and we just execute the pending actions that we have already added. And that's how you implement this Saga pattern.
So this is amazing. This is one of the this is where the developers were facing a lot of friction building these kind of systems, where now you can build responsive apps, immediately unblock the application, show an update failed, doesn't matter, still your transactionality is still there because there is a workflow taking care of things asynchronously underneath the cover to roll back and get the transaction back to a happy state. So amazing. So Yemen, like this transaction makes a lot of sense. I want to run a batch of those on a schedule. Show me what you have got.
Sure. So it will be very easy to do so, since now we have a new schedule available at the Temporal platform, and I have coded up this demo so that as soon as I click on this, I will have 3 schedules created on Temporal Cloud, and we can take a look on what they looks like. Let's try that. Head over. This is the new place where you wanted to manage your schedules. And here I have just created 3 of them, and let's take a super quick of each one of them. So this one is a every 5-second schedule. Nothing interesting there. This one is an hourly, and we wanted to do this during business hour. So you have to specify during your business. And what I specify is Pacific time, so during business hours. And you can notice that we have added some jitter. And because a lot of times when you have a lot of those scheduled to be fired at the same time, you don't want them to spike your downstream service. So you can add jitter, and this is now built in. Last one I want to show is the auto time zone switch. So see, I specified to be running on a Pacific time in the 2 p.m. afternoon, and it was able to adjust once the time zone shift, and you don't have to worry about that. Also, we added like a pause, unpause, all those features where a lot of people asking on our previous old cron style workflow, where you don't have a lot of control. Now you can do backfill, you can trigger immediately, you can pause, unpause, you can also update your schedules on the fly if you wanted to. So all of those are the new features that we added. We can take a super quick look on what the code looks like. See, this one is how easy it is. If you wanted to schedule a simple one, like every 5 seconds, during business hours, only from Monday to Friday, added jitter, specify your time zone, and more complicated, like you can specify the months you wanted to run, and specify time and day of week. So super easy. You just need to specify your schedule spec. Let's take a look on what it is looks like on all the workflows. Yeah, so as we would expect it, we see a bunch of transfer happening right now. For example, this one coming from account 41 to account 91, and we send over $10. So yeah, it's done.
Okay, so that's awesome. By the way, like this has been an area where a lot, like schedules is a primitive which we have built recently, creates a lot of flexibility, as Yimin has shown here, where you just define all of those things in a spec and it just makes that thing happen on a recurring basis for you automatically. So, but Yimin, like on one of the things that I'm noticing here is like all of those transfers are fixed amount, $10. Like, I don't like that. Can we make a change to the workflow logic to like call an activity which gets the amount to transfer?
Yeah, that will be super easy to do just using workflow. We just need to add one additional step. And I happen to already have them. So it's super easy. Just save this line, call an activity to fetch the new amount that we want for each transfer. And yeah, easy.
Easy? Okay, I know people in that room understands like adding that activity is not easy. Why? Because the moment I deploy this code, all of my executions which were running are now going to start failing with non-determinism error. And you are saying it's easy? Explain.
You are exactly right. And having to deal with this type of workflow logic change in non-backward compatible and then facing non-deterministic error is one of the major pain points that people complain. And we have been working so hard to address this by introducing a worker versioning feature. Now you will be able to do this safely with very simple change that you need. So besides making your code change, of course, the only thing you need to do is go to your worker code and see what I have said here. When you start your worker, you specify some of the options. And one of the key one is here. We wanted to use this feature to enable versioning. And then we just need to passing in a different version. So let's say we want to do a 2.0. So I save this, and I deploy this worker. What will happen is that this worker will now identify itself as version 2 to the temporal server. And any new workflow coming in will be automatically dispatched to this particular version. And only the new worker with this version will be able to process that task. your old workflow that will continue to run, the in-flight one, will continue to run on the old worker unimpacted. So let's actually, let's deploy this new one. As you can see on the left side is my old worker. So yeah, I just need to build this and so as soon as I hit enter, my new worker will be start taking over the new traffic, and old one will continue to run until it drains all the in-flight. Let's take a look in action. See, it's already taking over, and the left-hand side has been slowing down because no more new tasks will go into the left-hand side, and looks like it's very close to getting done. I think it would just take 5 seconds or something. It's probably done. Let's take a look on their workflows. So see, the number has changed. And now those numbers are different and not $10 anymore, but you still see some of them are $10 here, and if you scroll down, more and more of them become $10. So while this is interleaving, it is when both versions are having in-flight workflows and both versions are active. And then very quickly they drain all the old one, and now you are in a state where all of the new one is running on the new version.
So this is so cool. Like, I have so much PTSD, by the way, from making changes to my workflow logic and deploying. And I think with this feature, we expect like people can be more creative and more risk-taking and make changes and deploy their code to production quickly without worrying about non-determinism. So thanks a lot, Yamin. It's for the amazing demos. A huge round of applause for Yamin.
Thank you.
So, as you have seen, like we have been making tons and tons of investment to make this durable execution more and more attractive for other people to build their applications. We have a lot of sessions coming in. Like I think there's sessions about, like the entire SDK team is here. Please find them. Go ask your questions, talk about their use cases. We have sessions on Go, Java, and TypeScript later today. Please attend those. There will be tons and tons of information on those sessions, and then Python and .NET on tomorrow. As you have seen, we've been kind of pushing boundaries on the core platform side of things to make these durable executions more and more attractive. One of the things which has naturally started happening is people are using it for very, very mission-critical apps. This is where we feel we are kind of differentiating Temporal Cloud and doing tons of the investments on cloud to make Temporal Cloud the best place to run these workloads. So next I'm going to invite Preeti Somal to come up on the stage to talk about those investments.
Thank you so much, Samar. Thank you, and another round of applause. Those demos were just so fantastic. Thank you, Yamin. Great. Hello, everyone. My name's Preeti, and it's just such a privilege to be here today to represent the work that the very talented team here at Temporal has been doing. I'm going to talk a little bit about cloud, and then I'll also have Liang come up in a little bit, and we will definitely do demos. Sounds great. So let's dive in. So you heard from Max, kind of this paradigm shift and seeing durable execution and workflows everywhere. And I think you heard from Samar a little bit about reliably automating the world. Our goal with Temporal Cloud is really simple. What we want to do is build a utility that essentially runs everything that you all are building. We want you to be able to do this in as simple a way as possible, without having to worry about all the heavy lifting that goes into running the temporal service at scale reliably. So once again, you're seeing workflows everywhere, I hope, by now. And what we're doing is we are providing you this utility so that you can run them really, really easily. In order to do that, we've actually put in a ton of effort, both in terms of our operations, security, as well as automating the control plane, building a custom persistence layer so that we can run this reliably and at scale, and do this in a way that we can meet all the needs that are coming from our customers. Last year at Replay, we launched Temporal Cloud in GA, and we are so, so honored to report on our progress since then. We've hit a huge scale point. We have more than 600 customers running their applications on Temporal Cloud. We have more than 2,800 namespaces, and over 1.5 trillion actions since April 1st. So this is something that is really serious for us, and we are really, really honored that you're putting your trust in us and allowing us to run this utility for you as you automate your world. Now, how is Temporal Cloud different? We actually have a few talks later. So Sergey is going to talk about the control plane later today. And then Paul talks about our custom persistence layer. So if you're wondering sort of how we run Temporal Cloud, how we built it, those are two really good talks to go to learn more about what's going on with Temporal Cloud as well. All right, as Samar talked about sort of making our platform approachable, adaptable, and applicable, this sort of is a theme that runs through everything we do. And what I'm going to do is talk a little bit about some of the work that we're doing on the Temporal Cloud side. To help me with that, I'm going to invite Liang up on stage. Liang is in our engineering team for Temporal Cloud. And while he sets up, I'll introduce the first set of demos that we're going to do. So one of the clear themes for us that has emerged is making the cloud be very approachable for all the platform admins. What does that mean? That means that as you all are out there building your applications and more developers are coming in, we want to be able to simplify how authentication works, how you're onboarding users into Temporal Cloud, and how you're managing the workflow of those users, and namespaces. So we'll kick this off with a few demos. Are you ready, Liang?
Yeah, thanks,
All
Preeti,
right.
we're ready.
Let's switch to demo.
So one of the first things that I'm going to demo is the recent launch of API keys. So API keys will allow you as a Temporal user to interact with Temporal Cloud using the T-Cloud command line tool or through one of our APIs we just launched. So it's actually very easy and straightforward for you to just apply or provision your API keys. All you need to do is go to the Temporal Cloud UI, and in the settings page, you will see this new tab, which basically says API keys. There it contains everything you need to manage your keys. I already logged in as account admin, so what I'm going to do is I'm going to click this create button, and I'm going to create a new key for replay demo. And as I click this generate API key, it actually is going to show this string which I can copy over for my use in my COIs and my programs. And this API key will inherit all the permissions I have as my user.
That's great. Liang, thank you. And as you can see, this feature is in private preview currently. Liang, let's actually take a look at how we use this.
Sure. Have you guys all used T-Cloud CLI? So
Yeah.
T-Cloud CLI is the official tool which Temporal Cloud releases, which helps you to manage all your users' accounts and namespaces. And in the latest release, we added support for API keys. So what I'm going to demo here is I'm going to just use the T-Cloud plus the API key to do some CRUD on the users. So the first thing I'm going to see to show is that we can do this get operation, and I'm going to use this test user at temporaldemo.io, which doesn't exist. And you should be able to see the same information in the users tab I'm the account admin, but I'm the only lonely user in this account, which doesn't sound right. So I'm going to use the T-Cloud to invite some new users to the platform. And what I'm going to do is I'm going to invite this user called, again, test user at temporaldemo.io, and I'm going to assign a developer role for the user. So what this does is it talks to Temporal Cloud. It actually runs the workflow in the backend. It provisions the user account. And by going back to the UI, we should be able to see that the user is invited, and eventually it will be activated. We can go back to the CLI to do the same thing for the get operation, and now you will be able to get all the user information and permission information from the CLI as well.
That's fantastic, Liang. But we've got a large development organization, and we want everybody to use Temporal Cloud. Are you expecting me to run the T-Cloud command every single time?
Of course not. Recognizing this problem, we are actually...
You set this up well.
So I guess I just introduced, we are going to release a set of APIs for the CRUD of users, namespaces, accounts as well. Actually, this is the internal repo, but it contains all the protobuf definitions that you as a developer would need. I'm just going to show one of these proto definitions, which gives you like the get users, create users, update users, and changing user permissions. And with this, and this is an internal repo just because we are still in private beta, and we're going to open it in a few days after the replay. And that's how you would be able to use it.
Yeah, that sounds great. So once again, this is a feature that we are developing, and we will be releasing soon. The goal being you can go into that repo and you can take a look at all the API signatures. And again, as you can see, what we're really trying to do here is build out that sort of automation layer so that you can automate your usage of Temporal Cloud pretty seamlessly.
Yeah, and one of the ways, obviously, you can use it is by doing temporal workflows. So one of the things that I did with this API recently is that I wrote a very simple workflow, probably similar to what you guys probably learned from the 101 classes yesterday, which does this loop, and it basically does two things. It creates an activity, and it monitors a file. And I'll show you guys a little bit what file looks like. And then it calls into a bunch of these APIs that I just showed you to reconcile these users. So when I say a bunch of these APIs, it's just to make sure that we do idempotency on these update operations, and then it goes back into sleep. So I'm going to show you that this is one of the example of user files. Again, if you go back to the UI, you will see that we don't have, we have 2 users now, but we want to add more users. So in this file, we have admin user, which contains an admin access to the account. And then we have a developer user who basically has a write access to this namespace. And then we have a monitor user who has only read access. And what I'm going to do here is I'm going to start this workflow. And I'm going to start a worker here, which talks to Temporal Cloud. And then I'm going to just start this workflow. And while the workflow does its job and tries to reconcile the data, we just need to wait a little bit to see that this user eventually appears here on the UI. See here, we already have the admin user here. The only reason that we did it one by one is because these are all asynchronous APIs, so we actually wait for each of these users to be created before we process to the second user. With temporal workflows, you're free to spawn 3 Go processes and then do them in parallel.
Yeah, so as you can see, we see workflows everywhere internally as well. And so to show kind of the user management APIs, we're showing a workflow approach to it. Excellent. Liang, did you want to share anything else here?
So obviously, one thing that we can do with this is we can update this file, and it will get reflected in the UI.
Yeah. So the point being that we've got these primitives in place, and hopefully all of you can start imagining how this would apply to the automation needs that you have within kind of your processes around onboarding users, etc. All right, let's switch to slides again, and awesome. So we just walked through a demo. A quick shout out, the product forum later today there are more details on this and sort of more roadmap items. So definitely go find our product managers there and get more information on this whole sort of focus area for us. Let's talk a little bit about mission critical applications. You've again heard today how reliability and availability is sort of a core focus for us. And we showed you temporal cache, and hopefully that never goes down. But in all seriousness, we have a lot of mission-critical applications running on our platform, from payments, messaging, bookings, to tacos. Yeah, I know we're kind of in between you guys and lunch, so tacos it is. Anyway, so as we think about mission-critical applications running on our platform, one of our key goals is to bring more and more availability forward. And today, I am really pleased to announce that we are launching global namespaces in private preview. And so global namespaces is a feature that allows us to protect against region outage and takes us to 4 nines availability. Liang, how does global namespaces actually work?
Yeah, so global namespaces actually spans across multiple temporal clusters in different regions. So as you guys all know, while your workflows continues to make progress in the primary region, Temporal will be able to continuously replicate all these history events to a secondary region, and as part of that process, it also updates the workflow state in the hot standby mode. So when an outage happens in the primary region, a namespace failover will allow us to fail over your workflows to the healthy region so that they can continue to execute. And through the same process, we're going to fail over all your customer traffic into the same region. So by this whole process, it allows Temporal Cloud to continue to serve our customers' traffic for both the existing workflow executions and for your new workflow executions during a regional outage.
Wow, that's really compelling. How hard is this to set up?
It's actually pretty simple. As you can see from this slide, all you as a user need to do is to just select 2 regions. And you will have a global namespace, and Temporal Cloud will take care of the rest.
That is unbelievable. Are you saying I just need to click a little drop list and I'll get global namespaces?
Yes, that's exactly right.
Oh my gosh, I'm not sure I believe you. I think we'll have to show a demo here. Should we switch to demo?
Yeah, let's do it.
All right.
So here what we're going to do is we're going to show this demo. This is an awesome application which our Temporal SA team created. And this is, as you can see, it's a trivia game. What I'm going to do here is I'm going to launch, I already launched 2 game sessions. The left side one is powered by a normal Temporal namespace, and the right side one is for a global namespace. Before we dive into any of the details, let's try to play the game a little bit.
Yeah, I think I might need help with the baseball question. Who knows the answer to that? It's B.
Oh, it's B.
I should know that. I'm from the Bay.
Great. And you want to try the one on the right hand side? Like, which planet in our solar system has the highest average surface temperature?
Mercury. Awesome. So once again, as we're running through this game, this is literally the exact same code. There is a blog post that our solution architects team did on this game. It's just running against global namespace for one and not for the other.
That's exactly right. Actually, I need to create one more game. 1 second.
Awesome. And so as Liang is launching that, I think, Liang, the next step is for us to simulate an outage?
Yeah, so the way I'm going to demonstrate the value of global namespaces, I'm going to bring down the temporal cluster which powers both of the workflows and namespaces. Here I'm going to just launch this script. All it does is it's going to shut down the services, and then and we are going to see errors from both sides actually. What these apps does, as you can see, what these apps does is actually cause temporal queries to continuously watch for the game state change, because this is actually a multiplayer game, so other people can also play on this. I'm not demoing that multiplayer part. And also, as you can see on this right-hand side, we're currently connecting to US West 2 region, which is the region that I just brought down.
Oh, wow. Look at that. So,
And
yeah.
you're going to see two things here, actually. The first thing that you're going to see is on the right-hand side, the workflow continues to progress because the failover actually happened. So what happened is after we detect failure of that region, we are actually failing over the namespace to the other side of the region, which is a healthy region. And that's why we can continue to play this game. And we can click some of these buttons. I don't know which is the largest island in Caribbean. Cuba? Oh, sorry.
Puerto Rico?
I misclicked. I'm
Okay.
sorry.
All right.
But that's where we get all the regional resiliences there.
Yeah, this is incredible, and no puns intended, but this is a game changer, isn't it?
It is. As you guys can see,
Thank you, thank you.
I mean, this is a very powerful technology, right? It adds all these resiliencies to your application without you even change any of your code. But much more than that, we actually internally within Temporal, we use a similar technology which allows us to migrate all these workloads between temporal clusters for efficiency reasons and for infrastructure upgrades. And we do foresee in future we'll use a similar technology which helps our users to migrate their workloads from on-prem clusters to temporal cloud and vice versa.
Yeah, amazing. This is definitely not a trivial piece of technology. And you know, as Liang just mentioned, what we're doing here is sort of laying this foundation. And as you can imagine, you know, there are more use cases here for us to solve around migration that, you know, we will be diligently working on.
Yeah, and just before we finish,
Yeah.
I just want to mention that the DNS change also got propagated. The only reason that you guys probably see that get delayed is because of DNS caching and everything. But the traffics are actually routed to the new region. So thank you so much for.
Thank you so much, Liang. A huge round of applause for Liang here. And again, that's the link to the trivia game. It is a multiplayer game. It's really interesting if anybody wants to check that out. And there's more. You know, we've been building more on Temporal Cloud today. We've had the chance to talk about two main focus areas, but there's a lot more capabilities there. And again, I encourage you to look into all of that. And with that, I'm going to invite Samar and Jim back on stage to wrap us up here. Thank you.